Hello students, we have reached to yet another video on C. I have chosen the topic that is storage class in C, and the reason why I have chosen this topic is that this is the most fundamental part and often required in the DSA. So without wasting time, we should move towards the topic. See, I am writing something on the board and I will explain as I write. There are basically four categories of storage classes. The first storage class is auto. The second is register. The third is static. And the fourth is extern. Now, the question comes here that why we have four storage classes and what is the basic purpose of having these four storage classes. The entire memory allocation is being divided into four different categories. The first category is the storage area. The second is the initial default value. The third is the scope of the variable, and the fourth is the lifetime of the variable. Based on these four criteria, we have four different type of storage classes. So before explaining, I should write these four terms here. The first one is the storage area. So I am writing here storage area. The second is our default value. So I am writing default. The third is the scope. The fourth is the lifetime. Now, I want to basically divide these four storage classes into two broad categories. The first broad category is the memory and the second broad category is the register. So out of these four, this auto, static and extern, all these three are basically based on memory storage area. So I will write here M for memory, M for memory, M for memory and R for register. But there is a slight point that need to be mentioned here but not to be defined. I will mention but I will not define. What is that point? The point is that we have two types of memory area. One is your stack and the second is your data segment. So the difference between this stack and data segment I will deal in the next video. For now, I am not segregating what is the stack and what is the data segment. I am including this in the memory itself, and the second one is the register one. Now, what is the basic difference between a memory storage and a register storage? Memory storage means when the data is stored in the memory means RAM, the time to access the data is higher as compared to the register storage. On the reverse side, if we go to the memory part, since the size of the memory is large enough, that means that we can incorporate more data in RAM as compared to the register. So the decision you have to take as a programmer, that whether you need a space factor or you may need the time factor. If you need the time factor, what you will do? You will use the register one. If you need the memory factor, the size factor, you will go for the other three one, that is auto, static and extern. One more thing, this auto, static and extern are all commands. That means I can command the computer like this: static int x. This is my command. That means that the computer, the compiler have to declare x as a static variable. On the other hand, if I write extern int x, this also is a command. That means x is an external variable. But if I write register int x, it is not a command, it's a request. That means declaring a static variable is not up to us. It is dependable upon the compiler and the operating system. They both will decide whether to declare it as a static variable, a register variable, or a static variable or auto variable. Is entirely depend upon the scenario that is prevailing. That means if the registers are available, it will be given the register. If it is not available, the register variable will automatically convert it to auto variable. And a point to be mentioned and point to be noted: auto and extern are of the same storage class except one point. And what is that one point? The one point is that auto goes in the memory, especially in the stack. I will explain in the next video what is the difference. And the register goes in the register part, the CPU register part. Register declaration is a declaration, it's a request. If accepted, it will get the register of the processor. If not accepted, it will get the memory. Then the second point is that the type of variable that will be required in the register, it should be those variables where access rate is high. I will give you an example where I need a higher access rate variable, and that example is when I am talking about a loop variable. I am talking about a loop index. Since you have a loop and you want to execute that loop 100 times, what will happen? You are accessing the same variable again and again 100 times. So if there is a delay of 0.1 second also, you will feel that delay. So in that case, the register is a perfect one because the delay rate of the register is comparatively low. It is comparatively faster than the RAM or the memory part. The second important thing is that both the auto and the register has a scope local. Let me clear. Local scope means what? Local scope means that if, for example, if I declared a variable like this, if I declared a variable in a block, and whenever I say block, I basically mean to say a block means any block, or whether a loop block or a function block or any block. So for example, if I declared a variable in this block, and if this block is a function block, for example, it is a function block, name of the function is m. So a local scope means everything that is being declared in this particular body, this particular block, will be available here only. That means any request of accessing this block content outside the block will fail. And if this happens, the variable is termed as a local variable, a variable with a local scope. That means it will be created here, it will be deleted here. That means it cannot be accessed from outside the block. One more important thing, both the auto and the register both have the lifetime also local. What does this mean? This means that as soon as we go out of this block, the variable gets deleted from the memory automatically. So if I am here declared int x is equal to 10, this will be available till this point. As soon as we go out of this block and here we come, and again if I want to access this particular variable, I will have to create a new memory block in this block. That simply means that within a block, these two variables will be available, accessible, and will be in the memory. As soon as we come out of the block, these two variables will not be accessible and should not be available in the memory. So it is local in scope and local in lifetime. Now, the second two categories. Let's move to the static one. Often this static one is confused with the word const. So at initial stage, I clearly want to write this point. I clearly want to make you understand this point. Static does not mean constant. Please keep in your mind that static does not mean constant, because C language developers were not fooled that they have used two keywords for the same concept. If we have a const and if we have an static, both must be different, therefore we have two words. If they were the same, we don't have the two words. So the static is different from constant and should not be at any case considered same or similar. Static means a variable declared as a static will have the first thing the same, will be allocated in memory, no doubt. But the initial default value of the static variable is 0. In the same manner, the external variable, the initial default value is 0 and its memory area, storage area is memory. In this category, they are the same. The second important thing, static variables are declared once. That means if we call that variable again and again, that does not means that that particular variable is again created. That is, whenever we will create that variable again and again, it will not be created. Means, for example, if I have a block void sum, and if I have a static int, that is static int x, okay, is equal to say 10. And if this particular function is again called recursive manner, then it does not mean that new x will be created with a new value of x10. Means the static variable creation once, deletion once, and when deleted with the program. That means the lifetime of a static variable is the entire program. Means as far as lifetime consider, static variables are global. But if I say about the scope of a static variable is local. That means this x will not be available here, this x will not be available here, this x will not be available anywhere except the block. So the static variable, the memory area, the storage area is memory, the default value is 0, the scope is local, but the lifetime is global, declare once only, and at any subsequent call, neither the variable is redeclared nor the variable is reinitialized. It will only be declared once, and reinitialization is not with the static. But if I delete the static keyword from here, it will become auto, and the auto variable will be declared every time the function gets called. That means if again it is being called, a new x will be allocated with a new value of x10, then again it will be allocated, and so on. This can easily be checked when we can check with the address of the variable, but with the static one, it will not be recreated again and again. The fourth one, that is the external one. The external one have the area memory, fine, initial value 0, fine, scope is the entire program. That means if I declare a variable with external keyword, or if I declare a variable outside a function block, in both the cases, it will be treated as a global variable or external variable. An external variable is a variable which is available throughout the program. Whenever I say throughout, I mean that if the program is more than one file, in all the files it will be available. Okay, its scope is the entire program and its lifetime is the entire program. Means the variable will be created with the program and deleted with the program. Means once the memory is being once the program is being deleted from the memory, all the static variable, all the external variable will automatically get deleted from the memory. Okay. Now one thing last I want to mention here is that let's complete this table, because I think that remembering this table is more easy for you in the near future. So I will put here a garbage value. I will put here a garbage value. I will put here also a garbage value. And don't come confused with the word garbage and random. Huh? Garbage means those values which are being generated without our control, and these values are of no use for us. Random values are those which are generated by us for a particular purpose, and they have a purpose and they have a use. Garbage values has no use. Scope of the auto is local, scope of the register is local, scope of the static is local, scope of the extern is global. Lifetime of the auto is local, lifetime of the register is local, lifetime of the static is global, and lifetime of the extern is global. Okay, so here we will conclude our session for the day, and the session for the day, the giveaway for the day is 4 giveaways. The first giveaway is that the type of variable you declare to choose must be as per your requirement. If you need a fast access, go for register. If you need not require the redeclaration, go for static or extern. If you need to be declared in a memory and you may redeclare it when and where required, go for auto. The first thing. The second giveaway is that all these 3 except the register are command. Register declaration is a request. Depend upon the operating system and the compiler whether to avail that request or not. The third giveaway is that whenever you choose a variable to be declared as register, go for those variables which require fast access. My suggestion, loop index. My suggestion, array index. They all require fast access. Therefore, go for these particular cases. And the fourth one, if you don't write anything in a variable, it is by default auto. And if you don't write anything in a global variable, it is by default extern. Okay? And extern variable can be redeclared any number of times, but the first declaration will be exist. This is the same as we are talking about static. Static only once declared and once deleted. Extern also once declared, once deleted. Never redeclared. As many of time as you like you write, but the declaration will not repeat. It will be only one time declaration and one time deletion. Thanks for watching my video, and happy coding, happy learning, and happy learning C. Thank you.